Hey guys, it's James from SportsDataMarket.io coming at you with another sports data analysis tutorial. Today we're going to be using the premium tier of our NFL API and make use of the standings API to try to find out which teams were the highest scoring and lowest scoring teams going back to 1970. So let's open up this documentation. Let's take a look at this endpoint right here, NFL standings by year. This is the endpoint we're going to be using today to perform our analysis. So what I want to do today is I want to go back to 1970 all the way towards present, or the most recent season being the 2024 regular season. And I want to determine, based on points per game, which teams were the 10 highest scoring and which teams were the 10 lowest scoring. So lucky for us, we just have to use this one endpoint today. And so let's copy this and let's head over to VS Code. So I'm using Python today. I'm making use of a virtual environment as well as the request library. So you may need to create a virtual environment or pip install the request library. I'm also using the built-in JSON library. So let's get into it. I'm actually just going to create a simple variable just so we can call the endpoint to see the type of data that we get back, right? So I'm going to do request.get, punch in our endpoint here, NFL standings by year. I'm going to replace the year with the casted string. Let's say the 2016 standings. Awesome. And I'm just going to print it out on this next line so we can just see what we're working with. And let's run the script. Awesome. And so we get back a list of the standings. These are the list of the standings for the 2018 season, or 16 season rather. And we see that it's indexed. That's how it's indexed. The year followed by a space and NFL standings, which maps to a list of the standings objects. Each standing object has its own ID, the team name, the year, the division, their wins, losses, ties, win percentage, division record, more data. But today we want to focus on which teams were the highest and lowest scoring. And the method I'm going to be going about that is I'm going to be adding up all of the games that a particular team played. And I'm going to make use of this points for attribute right here. So points for means the amount of points in the regular season that the given team scored. And the reason I want to add up all of their games is because we have to think of, right, in recent times, the past couple of years, we now play 17-game NFL seasons. For a really long time, it was 16-game NFL seasons. And we're going to go back to 1970 in this analysis. And so we have to remember some of the earlier seasons in the 70s and whatnot played 14-game seasons. There have even been lockout seasons that have happened where there have only been, say 9 or 10 games. So we're going to analyze all of those seasons. And we're going to add up their wins, losses, and ties, and make use of this points for key. Put this all together, perform some logic, and try to see which teams had the highest points per game. I'm using points per game as a metric because, the total points scored is probably going to be biased towards teams that have had 17-game seasons and whatnot, or played more games. Points per game is a good indicator of just seeing who are the purely most dominant offenses. So yeah, let's keep coding. So like I said, I want to start at going back to 1970. So I'm going to create a variable called start year, and I'm going to set it equal to 1970. This is where we're going to start our analysis. And then I'm going to create a variable called end year, and I'm going to set it equal to 2025. We're recording this video in the off season after the 2024 NFL season concluded, so we're still waiting on the start of the 2025 NFL season. And then I'm going to create a list. I'm going to call it, I'll say standings list. And it'll just be equal to an empty list. Cool. And then I'm going to make use of a while loop. And the condition's going to be while our, so actually instead of start year, I'm going to call this current year. I'll be more descriptive, because I'm going to say while our current year, because it's going to change. While our current year is less than our end year, this is where we're going to perform our logic. And so the first line in our logic is we're going to actually want to get the standings data. I'll call it standings data. And it's going to be similar to our line up top. So I'm going to say request, this line up here, line 4, I'm going to say request.get. And it's going to be this endpoint with the replace and everything. But instead of replacing a hard-coded number, I'm going to replace this guy with current year. And then similarly on the next line, I'm going to say, I'll say standing JSON is equal to standing data.json. Cool. So looping through at this point, this should get us the data back for that particular year. And so we see how the data gets indexed with the year followed by a space followed by the word NFL standings. So we're going to create a string on the next line right here called index string. And I'm going to set it equal to the casted string of current year plus a space plus the word NFL standings. Cool. And then on this next line, I'm going to extract the data. So I'm going to say standings are equal to the standings JSON of our index string. And so if we think of this as a loop, right, every time we're looping through, we make a call to that year's standings, we index it with that index string, so that at this point will give us back this list, which is what we're going to want to iterate over to determine a team's particular points per game. So let's start looping. I'll say for every object in the standings, and then let's see what we want to strip out from each of these objects. So there's a lot of data, but what I want to keep my eye on, so I want to be able to see the team name, the year that they played in. I want to see their win percentage just so I can see how good they were for that year, get a gauge on if a team had a particular high scoring year but maybe didn't have a higher win percentage or vice versa, if anything stood out. And then I want to make use of their records, right? And when taking a team's record, I want to add these three together in a string format. I want to make use of the points for key to strip out the amount of points that they scored for that year, as we're going to need that to calculate our points per game. And then similar to our record, I'm going to keep track of our record, but it's going to be stringified so we can see, say, 14, 2, and 0. But I'm also going to want to make a variable called total games, and it's going to take the integer version of each of these. And the reason I'm going to want to do that is because that combined with this points for key is what's going to give us our points per game. Our points per game is going to be this points for key divided by the addition of the wins plus losses plus ties. That'll give us the total points scored for a regular season divided by the total games that were played, which will give us the points per game. So that was a lot of talking, but now let's get to the coding. So I'm going to say the first variable I want to take is team name, and it's going to be equal to the object of that team name key, as you can see. The next variable, I'm going to want to take the win percentage key. I'm going to want to take the year. The stringified record, I'll call it record. I'll set it equal to the string of object, the wins, plus I'll put a dash to separate them, plus the string, the casted string of losses. Finally, plus the casted string of ties. And then to calculate the points, the points per game, we're going to want to strip out the points for key. And then lastly, we're going to want to create that integer value of all of the combined games. So I'll say total, I'll call it total games, and it's equal to the non-casted version of wins, object of wins, plus object of losses, plus the object index of ties. Awesome. So this is all of the data that we want to extract on each iteration. And to get the points per game, I'm going to make a variable called points per game and set it equal to the points for divided by the total games object. And the last thing I want to do on this iteration is every time we iterate, right, I want to add to this standings list, right? And I'm going to add an object. So I'm going to say standing list dot append. Then I'm going to create an object. I'm going to make the key team name, map to team name, and so forth. Win percentage, maps win percentage. We want to include the record. Remember, this is the stringified record, so we can see kind of visibly what their record is, 14 and 2 and 0, whatnot. Points per game. I want that to be in there as well. Awesome. So what we did right here is we looped through, extracted the data, calculated the points per game, and on every iteration appended that to our standings list. And to make sure that we don't hit any infinite loops, once we're out of this for loop, we want to increment our current year, and this will ensure that we're going from year to year, 70, 71, 72, etc., and stopping before 2025. Awesome. So this is pretty much the logic, the bulk of the logic. I'm going to come down here and the last things we want to do. So this is going to give us, I'm going to run it right now, and we can see our standings list. But our standings list is going to be a large list composed of all of these objects. What we want to see for this video is which teams were the top 10 and bottom 10 highest scoring offenses. And so in order to do that, we're going to need to make use of the sorted function, right? So this is just going to be one long list, but since it has objects that have these keys we can count on, we can make use of the sorted function as well as the built-in lambda function that comes with the sorted function to sort on points per game. And sorting on points per game and making use of the reverse equals true will give us a way to separate the teams who are in the top 10 scoring, have been the highest scoring teams of all time, versus the teams that have been historically the bottom 10, the lowest scoring teams of all time. So here we see we got our data back, and what I just wanted to display here is you see how it's a really long list because this is all of the standings combined, all the data extracted from 1970 to 2025. So let's come down here and let's write these lines right here. And I'm going to say top 10 scoring teams. And this is going to be equal to, I'm going to make use of the sorted function. And the list we're going to pass in is our standings list. And we're going to make use of the lambda function here. So I'm going to say for every lambda object we had, I want to index on that object by our points per game key. And then this will give us a sorted list, but since we just want the top 10 most, I'm going to index it like this. So this will give us the top 10, the last 10 of that sorted list. And since we also want to see the bottom 10 scoring, it's going to be very similar to this line, but we're going to make use of the reverse equals true parameter in the sorted function. So I'm going to say bottom 10 scoring teams. And it's going to be similar sort fashion, but we're going to say reverse equals true. And so if you could imagine in this line, we're sorting in, it'll sort by points per game, and we want the last 10, which will give us the 10 highest scoring. If we were to sort it in reverse order and take the last 10, it would give us the 10 bottom scoring teams. And so this will give us our two variables. We could print these out right now. But what I want to do, instead of just printing them out as blobs, to make them a bit more organized, we're going to loop over them. So I'm going to make a variable here called team rank. And this will give us our countdown kind of from 10, 9, 8 in terms of the top 10. So I'm going to say team rank is equal to 10. And I'll say for every team in the top 10 scoring teams, let's print the team rank followed by the team index of team name followed by team index year followed by the team index of winning percentage. I'm going to print out these keys so we can see in kind of an organized list. And I'll say team of points per game. So we'll kind of have a side-by-side printout of 10, 9, 8 to see the top 10 and bottom 10. And then the last thing I want to do here is I want to say team rank minus equals to 1. Awesome. And then it'll be very similar. We'll basically do the same thing. I'll put a print here to give us some space between where we print out the bottom 10. And instead of top 10, it's going to be bottom 10 scoring teams. Awesome. Let's comment this guy out. Make sure there's no print statements. Let's run this script. And this should give us a printout of the top 10 highest scoring teams from 10 to 1 and the bottom 10 lowest scoring teams from 10 to 1. And this is based off of their regular season points per game. So, yeah, it'll be interesting to see. which teams show up here. Just taking a second for the scripts to run. That's it, right? Oh, here we go. Awesome. So this is the data that we see. So the Detroit Lions, this is from this past season. They cracked the top 10 at just over 33 points per game. We can see the highest scoring team of all time, the 2013 Peyton Manning Denver Broncos. I believe this was his first year in Denver. They just beat out the perfect 16-0 New England Patriots. Observing this, we can see that a lot of the highest scoring teams, I believe just off the top, I see 8 out of the 10, I think, are from 2000 onward. And a lot of them, right, I see 2018, 2019, 2024, 2013, right, 2011, 2012. We can attribute that probably a lot to the rule changes and things, the game kind of becoming very, very offense heavy. And now we look down here at the lowest scoring teams of all time. It's kind of flip-flopped. We see a lot are in the 1970s, the 90s. I think there's only, it's funny, there's from the highest 10 scoring, the top 10 scoring teams, only 2 of them are not from 2000 onwards. And in the top 10 bottom scoring teams, based off of points per game, only 2 of them are 2000 onwards. Everything, 8 out of the 10 are prior to year 2000. So we can see how just over time the game has flip-flopped, from being maybe very, very defensive in the 70s, 80s, 90s, and the modern, given the scope of maybe modern rules and whatnot, it's skewed very heavily offensive. But yeah, this is just a really cool analysis that we can perform using our API at sportsdatamarket.io. I hope you guys enjoyed this and found some cool observations in this analysis. Feel free to come over and tinker with our API. 75 calls free of charge. Thank you guys once again for tuning in. It's James from Sports Data Market.